Now that you've had a chance to think about it on your own, let's try and answer this question together. So we're looking at a particle that goes from position 1 to position 2. It's translating in a straight line. And we want to know how the angular momentum when the particle's at position 1, about this point, compares to the angular momentum at position 2, about the very same point. So what we've drawn here is the r vectors for the particle at position 1 and the r vector for the particle at position 2. So since angular momentum deals with the r vector and the momentum vector, we know that the momentum vector is staying the same. We have the same mass and the same velocity at each point. So what you might be thinking is that maybe, okay, the one with the bigger r vector, it's going to have the bigger angular momentum. However, because there's a cross product involved, we know that things could and actually are a little bit different here. So when you take the cross product of this r vector with this velocity vector, really the only thing that's surviving in the cross product is the perpendicular component of the r vector. So one way to write the magnitude of the angular momentum is to say it's r perpendicular times p, which in this case would be r perpendicular times the mass times the speed. Again, right now we're just talking about the magnitude. And we can see that r1, the component of r1 that's perpendicular to the velocity, is this horizontal component right here shown in red. But that is exactly the same as the perpendicular component for r2. And actually at any position along this line, I would get the exact same value for the perpendicular component of r. So what this means is that the angular momentum at each of these points about this dot here is exactly the same. So, and one more thing I want to say about this is that we just calculated the magnitude of the particle's momentum. We should also think about the direction, and the direction is given by the right-handed rule of the cross product. So let me just go ahead and look at the position 2. I lie my right hand along the vector r2, and I curl my fingers in the direction of the momentum, or in this case, the direction of v. And I get that the cross product points out of the page at me, or I could think about that as being in the counterclockwise direction. All right, so with that in mind, I want you to think about this question. Now we have two objects that are moving according to the diagram shown here, and we want to figure out what the total angular momentum of the two object system about this point is. So take a minute to think about it before starting the next video.